Hi everybody. Today, let's have a deep dive into the MIND diet and how its circulating metabolomic profile is linked to cognition in middle-aged and older adults. Dementia, a condition that affects memory, thinking, and daily functioning, impacts millions worldwide. It's not a single disease, but a collection of symptoms caused by disorders like Alzheimer's. With limited treatment options, dementia is a growing public health challenge. But here's the good news: research increasingly shows that what we eat can influence our brain health. Among various diets, the MIND diet, a combination of the Mediterranean and DASH diet, stands out for its potential to protect against dementia. In our latest study, we delved into how this diet may work at a molecular level, identifying metabolites, or small molecules in the blood, that could mediate its effects. Using data from two large UK studies, we explored these fascinating links between nutrition, metabolism, and brain health. This study leveraged two well-known cohort studies, the UK Biobank, UKB, and the Whitehall II study, WH2. The UKB dataset was divided into two groups, a discovery cohort and an internal prospective validation cohort, while WH2 served as an external validation cohort. Altogether, the analysis included nearly 46,000 participants from UKB and over 6,000 participants from WH2. We began by identifying metabolites associated with adherence to the MIND diet using a robust discovery validation framework, incorporating both internal and external validation. Next, we developed a metabolomic signature score, or MIND-METS, as an objective measure of MIND diet adherence. Finally, we examined how much of the association between the MIND diet and cognitive function could be explained by this metabolomic signature score. Adherence to the MIND diet, indicated by higher MIND score, was consistently associated with 47 metabolites in the UKB and WH2 cohort, including HDL cholesterol, lipid markers, fatty acids, and one inflammatory marker. Higher MIND score correlated with higher levels of unsaturated fatty acids, omega-3s, and ketone bodies, while inversely associated with VLDL-related measures and inflammatory metabolites. Among food groups in the MIND diet, fish showed the strongest associations with beneficial metabolite profiles. These findings align with prior evidence linking similar metabolites to the Mediterranean and DASH diets and suggest that the MIND diet fosters metabolomic profiles supporting cognitive health. We used a statistical method called elastic net to simplify the data and create a metabolomic signature score, or MIND-METS, to represent the MIND diet. Out of 168 metabolites, 41 were selected. Positive scores were given to healthy fats like omega-3s and linoleic acid, while negative scores went to less healthy markers like saturated fats and certain inflammatory molecules. The MIND-METS was moderately linked to how well participants followed the MIND diet, with correlations ranging from 0.27 to 0.36 across different groups. This means the score does a good job of reflecting MIND diet adherence. We explored how the MIND diet and its metabolomic signature relate to dementia risk and cognitive function. In the UK Biobank, higher adherence to the MIND diet and a better metabolomic profile were linked to a significantly lower risk of dementia, with a 8 to 12% reduction in risk per standard increase in these scores. Half of this effect was explained by the metabolomic profile. In the Whitehall II study, the MIND diet was also associated with better cognitive performance, with a 0.03 unit improvement per standard increase. The effect was partly mediated by the metabolomic signature. Before we wrap up, here are the key takeaways from today's episode. First, we found that following the MIND diet is linked to better metabolic profiles, including higher levels of beneficial fats and cholesterol, and lower levels of potentially harmful metabolites. Second, we developed a metabolomic signature called MIND-METS, which was associated with a lower risk of dementia and better cognitive performance. Third, our research suggests that the MIND diet supports cognitive health, in part, through its impact on metabolic health. And finally, while our findings are promising, more research is needed to better understand the mechanisms behind these results, especially in populations outside of the UK.